What's up? Welcome to Quicker Calc. I'll make these videos for the AP Calc AB/BC curriculum, but they can also be applied to any college level calculus course. Hopefully from the last video, you have a good grasp on what the derivative means conceptually. Congrats! Now the most difficult part of derivatives is solving some of the more awkward looking equations. If you know these rules but need practice, skip towards the end and attempt the problems I've made, and use the rest of the video for help or reference. If you're completely lost or don't know, just go ahead. Alright, so if we have a function f of x equals 3x squared, we're going to use the power rule when we take the derivative and end up with 6x. Easy enough. This is when things get weird, but there's a handful of rules that can be used to help solve these. So if we start drawing tangent lines in the sine function graph and seeing what the slopes are, and then looking at the values on the cosine function graph, you can start to get the idea that the derivative of sine x is actually cosine x. The derivative of cosine x ends up being negative sine x, which means that when you take the derivative of sine x 4 times, it comes full circle and ends up back at sine x. Here are all the other ones. I won't go through the exact breakdown and proofs involving trig identities, and while it's good to grasp the relationship between sine and cosine, you're better off practicing and memorizing the other ones and trying to break it down conceptually. You have to know all of them for the AP exam, but the ones boxed in red are definitely the most important. I cannot speak for the college classes, but for the AP exam, they really only care about two things. This is a funny function because, like a bad ex-boyfriend or girlfriend, by itself it will never change. The rate at any point is always equal to the y value even after taking the derivative the second or 1/millionth time. I do want to make note that the power rule does not apply when there's a variable in the power. This will be important later. You can also see here that the derivative of ln of x will be equal to 1 over x. When two expressions are multiplied by each other, refer to the product rule. Treat both parts as its own easily differentiable function. We'll be going through a kind of problem like this by making a derivative sandwich. When making a perfect sandwich, you have to plan and organize everything accordingly. I'll explain this methodology analogous to solving more complex derivatives. This rule, the product rule, is our holy sandwich list of what we need for our sandwich. You can't make a ham sandwich with turkey, just like you can't use quotient rule for product rule. We don't have turkey in the fridge, just like we don't have a quotient in our function. So, we'll gather our ingredients according to the sandwich we need. To avoid confusion, it doesn't hurt to lay out all the functions and derivatives we need. Just like if you make a perfect sandwich, it's good to have all of your ingredients prepped and in front of you. The easiest part at this point is differentiating and putting it all together according to our formula. I'd like you to pause the video right now and try to solve this in terms of the product rule. Alright, so it turns out product rule is unnecessary when there's a constant present with a trig or log function. Just keep the constant and take the derivative of the function. This is very similar to the product rule, as in we're going to treat both parts of the original function as their own. The actual equation used when deriving it is a little different, but it doesn't need to be overcomplicated. Just stick to the equation and make sure you don't goof up on the algebra. One of the things about quotient rule is that there are times when it may be far more convenient to rearrange the equation algebraically and solve it as a product. I'll solve it both ways, and I'd recommend you do as well to make sure you grasp both equations. So, this looks kind of terrible, but once we go through some examples and see what it's about, it's not that bad. What's important is understanding that there's a sandwich inside of our sandwich, which is a bit unusual, but we have to be careful and make it work. First, we need to identify the two functions that we need to differentiate to get what we need. When we differentiate f of g of x, the inner function does not change, only the outer functions, so while cosine will turn into negative sine, the 2x squared is not going to change. Then, we'll multiply by the derivative of the inner function, 3x, to get our answer. Remember when I mentioned we talked about e to the x earlier? You're likely to be asked to take a derivative like this. According to what we know about e to the x and the chain rule, the derivative here is going to be the derivative of the exponent multiplied by the function. So the inverse trig functions are not as predictable in kind as our original trig functions. These are going to be their derivatives. I know they're ugly, but fortunately for the AP Calculus curriculum, you only have to know these. I'm not going to explain the derivations or anything, it's just important to know that these are what they are. Some things to remember to avoid slipping up on taking these derivatives is that we keep constants when they're being multiplied, and we incorporate the inner function in its entirety into the x values in the derivative. Also, don't forget the chain rule. Here's a cheat sheet with the information that you will have to remember. Use it while you're practicing and ingraining these formulas. It is very important to practice these different rules and problems, so I got 8 practice problems with answers once they've been attempted. They get harder as they go on, but if you feel comfortable enough with some of the questions, try the harder ones. I had a lot of fun with the last two since they involve multiple rules. If you're interested in doing them, the answers will be up shortly, so pause the video now. Here's number 8 solved using the quotient rule. And here it is solved using the product rule. Also, I must confess, I lied. You cannot take every derivative. There's one more super easy topic I have to talk about in my next video. So if you enjoyed or it helped or you learned something, share with a friend who may need some review. Thank you for watching and have a great day.